All right, today's topic will be on geometry. I begin with a couple of problems from homework. So the first problem is about, okay, you probably, some of you already finished the problem, okay? So this is a square, and I have a circle around that, okay? Now, we are given information. This length, the piece, okay, is going to be equal to the radius. Okay, so you have to, for a geometry problem, you have to connect important points by straight lines first. So this is an intersection point as important points. The center is the important point. So you just draw the line, connect them. Then you realize that what you get is an equatorial triangle. Okay, that's equatorial triangle. Okay, you will get equatorial triangle. I'm going to call it A, B, and C. Okay, so the triangle ABC is equilateral. Okay, that's a very important observation. Okay, you have to use all the given information. Okay, now, so this is radius R, right? And this side is called A, the length. So we want to find out, okay, we want to find out the ratio, find the ratio of the area of the squares and the area of the circle. Okay, so you, basically, if you know the relationship between A and R, then you solve the problem, right? Okay, how do you find the relationship between A and R? Well, step by step, right? And is this equilateral triangle? So if this height is called H, then you have another identical equilateral triangle here on the other side, right? So that means, yeah, that's also H. So you see that A is going to be 2 times H. Okay, I'm trying to find the relationship between A and R, right? That's the next step. So, but H is the height of an equilateral triangle. So by we know that it's going to be square 3 over 2 times R. Okay, if we have a triangle like that, okay, this is going to be 30 degree, that will be 60 degree, and if this R, this is H, right? What's the relationship? You know, okay, and this side is half R, so you can find out R, right? H is going to be, if you want to use a Pythagorean theory, is going to be R squared minus R over 2 squared, and that finally gives you 3 over 2 and times R. Okay, so that's how do we get this? Okay, so now after simplifying, so A is going to be square 3 times R. Then the ratio is obvious now, right? It's a square 3R squared pi R squared, and after simplified, R squared is gone, so the ratio is 3 over pi. Okay, this is independent of the size of the circle or of the square. Okay, this proportion, preserved when you change the size of the square. Okay, so what do we need here? We should first of all you have to draw the addition lines. Okay, remember for geometry problems, for most of the problems you have to draw addition lines connecting important points. Okay, then based on the given information, you should recognize that this is an equilateral triangle. Okay, then you find that you write down what you have to find out: A squared over pi R squared. Then you realize that you should know the relationship between A and R. Then you look at the picture. How can you find the relationship between A and R? Right, A is going to be the double of the height of the equilateral triangle. Okay, then you find that express the height of the equilateral triangle in terms of the side length, which is the radius of the circle. Okay, so that's how to solve the problem. Okay, step by step, right? All right, so second problem, probably, yeah, at this, you draw the picture first, right? The picture is not given, so let's draw the picture. Okay, it's a rectangle, so you make it a little bit longer. Okay, then you also get E is on the DC side. Okay, so the area is a triangle ADE. That let's color it. So this is a right. Compare with the other one. Right. So you compare these two areas, and the ratio is 1 to, I think it's 1 to 5, right? 1 to 5. So because this area is 1/5 of the area of the quadrilateral. Right. Now, what do we have to find out? We have to find out the ratio of the length of a segment DE and DC. Okay, I'm going to denote DE by X. Okay, and the EC. Okay, and I'm call it Y. Okay, we don't know this, right? Those are all unknown. Those are we don't know. Okay, and then the height is H. About that. So what do we have to find out? Write down the given information first. Okay, and then given information, the area of the triangle X times 8, right? And this should be equal to 1/5 the area of what? Area of the trapezoid. So this side is X plus Y. So trapezoid is the average length of the base and the two bases. So X plus Y and plus Y, right? That's how do we find the area of the trapezoid times the height. Okay, that is given. We have to find out DE and DC. So DEN is X, DC is X plus Y. Okay, basically you have to find out the ratio Y over X. Okay, so you can also express this 1 over 1 plus Y over X. So you basically just need to find the ratio X to Y. Okay, right? Or Y to the X. So from the above identity, can we do that? Yes. First of all, you cancel 1/2 both sides, then you cancel X, then you cancel H. So what you get is you get X plus 2Y. See, right? And 1/2 is gone, H is gone, and right? Then you say, okay, that's easy, right? Then you multiply both sides by 5x is X plus 2Y. Then, and from here, the 4x equals 2Y. And I think Y over X is going to be 2. Okay, so now Y over X is 2. So that implies D over DC is going to be 1 over 1 plus 2, which is 1/3. Okay, right? So to solve these type of problems, if you don't know the dimension of that, then just introduce the variables, okay? Just call one side as H because they're going to cancel out eventually, okay? Just like the problem before, you let R denote the radius because you do not have a fixed size of the circle and the square, right? Circle and the square. So you just let R to denote the radius, and the A to denote the edge length of the square. Then you find the relationship. Okay, similar problems here. That's the reason you have trouble to solve the first problem, then you have trouble to solve the second problem, because you don't want to, you see that, the dimension is not fixed. Okay, if the dimension is not fixed, don't worry about that. We are talking about the ratio. When we were talking about ratio, the dimension is not fixed, but the relationship between the sides are fixed. Okay, if you enlarge this, this rectangle, and as long as you keep the ratio of the areas, then you will keep the ratio of the sides. Okay. All right. So the last problem, the third problem. This is before we talk about this problem, let's see how do we find the area, volume of the cone. If we have an H, this is the radius R, and this is a capital H. So the volume V is going to be 1/3 of pi R square and H. Okay, that is the volume formula. Okay, that is the volume formula. Okay. Now you have the picture. You cut the cone into how many sides? 1, 2, 3, right? That's how many sides? Yeah. So you have a 1, 2, 3, 4, 4 pieces. Yeah, 4 pieces. Right. So I'm going to, for the simplicity, I'm going to denote the first piece, which is cone. So radius by R. Okay. And the H is height ahead. Okay. So that's the first one. H is the height is H. This is R. Okay. Then let's see. This is triangle in the middle. I cut it. Okay. So this is a 1, 2, 3. Okay. The radius, this one being R1, that be R2, that be R3, that be R4. Okay. I want to find the relationship. Okay. R1 is R, right? R2 is going to be 2R. Now I'm going to prove that why it looks obvious. R3 and R4 is going to be 4R. Okay. That's just because by the similarity of triangle. Okay. By the similarity of triangle, yeah, by the similarity, for example, I want to show you why R2 is going to be. Okay, this is a triangle, right? The first one, it's R, here's H. Then another triangle, as this side is 2H, right? Because those sides are LH, right? They have the equal height. So then this must be proportional, right? So this must be 2R, clear, obvious. So that's why R2 is going to be 2R, R3 is 3R, okay? Now, once you recognize that, then we can find the volume of the largest piece and the second largest. Okay, so how to find the volume of the largest piece? Okay, largest piece. The volume of the larger piece, it's not a cone, but we can use a subtraction method to find. So first of all, this cone through 1/3, okay, times pi r is 4r, right? Okay, square, and the height is 4h because you have, yeah, h, right? So it's the height, h. So and forget 4h minus 1/3 pi and the cone on the top, right? The subtraction method. Then you get the volume of the slide. So this will be 3r squared, 3h. Okay. So we are talking about, this slide, right? Then you use the subtraction method to, we use the subtraction method to find out, find the area, find the volume. So that is the largest piece. Okay, you can simplify this. Okay, you can simplify this. Then you find the volume of the second, right? So what is called there? It's called the second largest. Second largest is the same idea. 1/3 pi the base 3r squared and 3h minus 1/3 pi, and that will be 2r squared and 2h. Okay, so that is the second largest. Okay, we're talking about second one. Okay. All right, so all I have to do is just find the ratio, right? And then you will get the answer. Okay. So the ratio, let's say what should be on the top? The ratio of the second largest to the volume of the largest piece. So the ratio, okay, the volume of the second largest and the volume of the largest, okay, is going to be, okay, and 1/3 pi, I think is 3 cube and r times h minus 1/3 pi 2 cube r square h. Okay, the bottom part is 1/3 pi 4 cube r square h and 1/3 pi 3 cube pi r square h. Okay, so after you simplify it, you will get, I forgot the right answer. Yeah, but anyway, so you get 3q minus 2q and then 4q minus 3q. Okay. Okay. So that would be the answer. Okay. If you want to simplify it, I'm going to double check. Okay. I have to do a computation. I don't know the answers. Okay. 3 cube is going to be 27 minus 2 cube is 8. So the top one is 19. Okay. Then 64 minus 27, so 37. I think that is correct answer. It's pretty strange number. Right. It's not a square, it's cube. Okay, it's a square. Okay. What are you talking about? The problem. So we are working on the third geometry problem. It's cone. Okay, it is cone. Okay, it is cone. So Alex, you just get into the classroom a little bit late, and Alex, right? But please use a link next time. Do not enter your name and the email address again over. Okay. Once you enter that, you will check the email. You get the link automatically in the email. Okay. Then bookmark the link. So next time you just click the link. You don't need to enter your name again, because every time you enter the name, you re-register. So I get too many identical names on the list. Okay, clear. Unless, okay, you can write down the zone ID number, the password. So sometimes, if the original computer is not available, then you can quickly get in the classroom, even on your cell phone when you sit in the car. Right. All right, so those are the geometry problems. Yeah, I saw that. You just get in after the class start because you registered again. All right, so let's take a look at the next problem. Let's take a look at the next problem. Okay. Here's this is a not difficult problem, but I wanted to do that. Okay, then we before move on to the next one. So I have a circle. The area of okay, so I have a this is the center. Okay, center, and this I draw the points here and here. Okay, this side is 8. This side is 6. Okay, this is the diameter. Okay, so now I have a color. This is a shared region. Okay, so what I want to do is find the area of the shared region. Okay, in terms of pi, but don't estimate. Okay. Don't estimate. Right. So you have to recognize that it must be a right triangle. Okay. Once you know this is right triangle, then the other side, okay, if this is radius r, right? So the 2r is going to be equal to 10. Okay. So that implies r equals 5. Then all you have to do is just take the difference. Okay. The area is going to be radius, the area of the circle minus the area of the triangle. Okay. Okay. So it's 25 pi minus 24. Great. Good job. Okay. Our next problem. Okay. Let me draw the picture for you. First, I have two circles, congruent circles. I connected the two centers, and I have another point above that. Okay. So that's a Q, that is point R, that's O, and that point is A. Okay. We are given the following information. Each of the circles have radius 8 units. So the radius, given information, the radius is going to be 8 units. And we also know that we also know this is a line and passing through that. Okay. Okay. RP tangent to both circles. Okay. And the QA, we are given information, is 1/6 of QP. Okay, so we know the ratio of those two. Okay, so this is a okay. QA is going to be QP. Okay, so we compare. Okay, QA is going to be this side. Okay, QP. Okay, it's the whole length. Okay. All right, so the question is, find the parameter of POQ. Okay, find the parameter of the triangle POQ. Okay. All right. So the radius is going to be 8. Okay, so that's the radius. That's the same radius. Okay, so it should be clear, right? How do you find the okay, all added together? Yeah, that's right. That's not difficult, right? Now, grant so 112. Yes. So what you do is you have to find out. You see, QA is the radius, right? So that's why QP is going to be 6 times QA, which is 6 times 8. It's 48. So the radius, that's why it's a parameter, right? QP plus OP plus OQ, just add them together, the parameter, right? It's a 48 plus 48 plus twice times the radius, 8. So the answer is 112. So there's no need of computation, just a basic computation. Okay. Now, our next problem, you do need some computation. Here we have a circle. Okay, inside circle in the equilateral triangle, we put that. Okay, equilateral. Okay, and the circle has a diameter. Okay, equilateral. Okay, the diameter 9. Okay, the diameter equals 9 of the circle, and you have the equilateral triangle inside. Right. What is the area of the equilateral triangle? Okay. And so the equilateral triangle is inscribed in the circle with diameter equal to 9. Okay. All you have to do is find the edge length, right? No, actually the edge length is the height. Well, first of all, we have the area formula for the height, right? You need to find the height also. Okay. So what we're given here is a radius, right? So if we can express the radius, if we can express a and h in terms of r, then we solve the problem. Okay. Yeah. So we're trying to express h and a in terms of the radius now, because radius is given, it's half of 9. Okay, well, I think I know the answer is correct. Okay, I'm going to, I probably can express everything. Let's go backward, find the relationship, okay? So this is R, right? So first of all, H is going to be square root 3 over 2A, okay? Because this is a special triangle, using the equality triangle, right? 30 degree and 60 degree, right? I already mentioned here's A and this is H. That's a relationship, okay? Here's half of it. Okay, then you look at the right triangle this way. Because this right triangle, okay, it has this side is half of A, this side is R, and the other side is H minus R. H minus R, right? Right? There's top part. So then you find the equations among them. Okay, so you will get, okay, H is going to be square root 3 over 2A, right? Okay, so write down the equation, square root 3 over 2A minus R squared, right? Plus half of it squared is going to be equal to R squared. Okay, I think this is also special triangle. So So you can, this angle, okay, this angle, let's take a look at what is the angle here, okay? Those two angles should be the same, right? Yeah, these two angles should be the same. So, so it's a 30 degree each. So from here, you maybe quickly get the relationship between I and H. Otherwise, you can solve from here. So what you get here is going to be, okay, is going to be, yeah, let's multiply this out if you want. Okay, so we have a square root 3 over 2, right? A square minus twice and r square, and a over 2 square equals r square is gone. Then from here, you will get, 3 over 4 and 1 over 4 is just a square minus square 3 AR equals 0. Okay, so I is going to be 1 over square 3A. Okay, so that's the relationship. Okay, so or A is going to be square root, right? Or A is going to be square root 3 R. A is going to be square root 3 R. Okay, so so now, yeah, A is a square root 3 R. So so H is going to be square root 3 over 2A. So then square root 3 over 2 square root 3R. So it's going to be 3 over 2R. So now you have a express A and H in terms of R. Then you can find the area. The area of the triangle is going to be half of the base times the height. Okay, so it's going to be A is going to be square root 3R. H is going to be 3 over 2R. And the answer is 3 square root 3 over 4 R squared. Okay, so that is so we express the area of the equilateral triangle in terms of R. Then if R is given, then solve the problem. Okay, so the when if I equals 9 over 2, and that is going to be 9 over 2 squared. Okay, and if you multiply this out, that's going to be 243 and the square root 3 and over 4 times 4 is 16. Okay, so that is answer. Okay, if you want to estimate, it's 26.3, not 20.25. All right. This is about the equilateral triangle inside a circle, right? And you can find the relationship. Okay. So a quick way to do is probably maybe I didn't spend too much time here. So this is a radius, right? And this is a half of A, right? If you recognize this is going to be 30 degree, and right, and this will be other side will be half of R, okay, right? Yeah, half of R, and the height, right? This will be R. So you already know express R in terms of height in terms of. So all I have to do is half of A should be, okay, my file is gone. Okay. Yeah. So this is a half of R, right? Because 30 degree corresponding to 30 degree. This is still R. And half of A is going to be square root 3 over 2R. So A is going to be square root 3R. Okay. So yeah, A is a square. So you can quickly get the area of the triangle is going to be half of A times H. And A is going to be square root 3R. h is going to be 3 over 2r. Okay, so you will get 3 squared 3 4 over r squared. So express area in terms of radius. Now we can apply the same idea, slightly different. Okay, it's not a you cannot get a because equilateral is so special. You get a special triangle inside. Now this time we still have a circle, but now you don't get an equilateral triangle. You get an isosceles triangle. Okay, this isosceles triangle was equal sides, 5 and 5, and the base is 6. Okay, and find the radius. Okay, find the radius. Now, to solve this problem, I prefer to get a very general formula. Okay, I call this side is A, this side is A, and that side is B. Okay, I want to express R in terms of A and B. Okay, so you get the most general formula. How do we get? How do we express R in terms of A and B? So remember, in geometry, you have to draw some addition lines. So connect important point. So center is the important point, right? Center is the important point, and then you connect, vertex, maybe extend it. Okay, then you have to connect those 2 points. So you will see then the equilateral. You will see a right triangle inside. Okay, can you work on this right now? I'll give you a minute. Okay, to think about a half minute. Okay. If you're able to find out the right triangle, express each side in terms of some unknowns, then you apply, before you apply the Pythagorean theory to the triangle. Okay, then you apply the Pythagorean theory to the triangle, then you set up an equation. Okay, I hope you get it. Nobody show me. Okay, so look at the right triangle here, right? So this is the right triangle. I'm going to express this right triangle. Okay, this side is the radius, right? And this side is going to be b over 2. Okay, now other side. The other side is going to be, I told you, it's going to be h minus r. The height is h. This side is r. So h minus r is going to be the height of this right triangle. And how can I, actually, I can figure out what is h, right? H squared plus half of b squared equals a squared. So h can be expressed in terms of a and b, okay? So we keep it here. So now I apply the Pythagorean theory again to this triangle. So h minus r squared and plus b over 2 squared equals r squared, right? So expand it. So r squared is gone. What I get is here 2hi equals h squared plus b over 2 squared, right? Clear? Yeah. Let's double check. Yeah. So clearly b squared, h squared is going to be a squared minus half of b squared, yes. So you get this formula. Then the triangle here, h minus r, and this side r, this half of b. Okay, good. So you expand it, right? And then you know h squared is going to be a squared minus half of b squared plus b squared. So that actually cancels out. You only get a squared. So I equals a squared over 2h. But h is going to be square root, right? A squared minus half of b squared. So that is a relationship between r and h. Okay. So if you know b is going to be, so if we find the a and the b, right? Then you can just plug the number into this formula. Then you solve the problem. So that's how do we, that is how do we get it. Okay. So we applied the Pythagorean theory twice. First of all, you get the height of the triangle. Then, then you can express each side of this shaded right triangle in terms of in terms of I and A and B. Then apply the Pythagorean theory, you get an equation. Then you can solve for the radius R. Okay. Our next problem is I have a two congruent larger circle, identical. Then I draw another small circle inside here, put it here, okay? So we get ABC, the circles ABC tangent to each other, okay? Okay, this is A, B, and the C. So the radius, this one's radius is going to be 4. This is also the radius of 4. Okay. And this is the radius is going to be 1. Okay. Find the area of the triangle ABC. Okay. ABC connect to the centers. So A, B, C are the centers of those circles. I have two congruent circles, right? And each of them has a radius of 4. And then I have a tiny smaller, I have a smaller circle put on the top. So now you get 3 centers and form a triangle, and trying to find the area of this triangle. Okay. Okay, please work on this problem. All right, so, okay, I see some of you get answers. So this is a triangle, right? And you see it's you have to find out the size different, right? So the base is going to be 8. This side is going to be 1 plus 4 is going to be 5. So you get the triangle. Here's a 5, here's 8, here's a 5. Actually, that's how do we, then you find the area of the triangle. Then you draw the height, it's h. This side is 4. So obvious h is going to be 3. Okay? So if h is 3, then the area is going to be half of the base times the height. So it's going to be 12. Now, here's my question. For an equilateral triangle, for an isosceles triangle, you can quickly get the area, right? If I give you an arbitrary isosceles triangle, and this side, for example, 26, this side is, hold on. Yeah, this side is going to be 12, this side is 12, okay? Then how do you find the area? Okay, all you have to do is find the height, okay? And it's easy to find height because it's an isosceles triangle. The height is going to be, right? So it's because it's an isosceles triangle, so this side will be 13. Then h is going to be, it's by the Pythagorean series, 13 squared plus minus 12 squared, right? It's 169 minus 144, and that is going to be square root of 25, which is 5, okay? So then the area is going to be half of the base times height. And then you simplify it, and you will get 13 times, then 13 times, 13 times 5, it's going to be 65. However, if I change the size, okay, I randomly pick up the numbers, okay? So this side is 7, This side is 8. And the other side, 7 plus, it is going to be 15. But I put 12 here. Okay. So this is indeed a triangle. And find the area of this triangle. If any of you can do this problem, this triangle is uniquely determined, and all the 3 sides satisfy the triangle inequalities. Well, you can use the same idea to find height. That's not easy to find height. You draw the line, okay? But it's not symmetric. So this side is x, this side is y, this side h. So if you don't have any other formulas you can apply, then you have to find the h, x, y separate, okay? So you apply the x plus y is going to be 12. That's one equation. You have 3 unknowns in this equation. So h squared plus y squared equals a squared, right? Then x squared plus h squared equals 7 squared. So you can find x, you can find the y, you can find the h. Okay. Then you solve the problem. There's another formula I want to mention, but let's try to solve this equation for h, for h and x and y. Okay. So how do you solve this 3 equations? Well, use the elimination method. Equation 2 minus equation 3. The left-hand side is y squared minus x squared. It's x squared minus 7 squared. How do I do the x? How can I do that, right? So 8 minus 7, 8 plus 7, so it's going to be just 15. 15, good. But on this side, it's y minus x, right? Y plus x. Okay. And that's going to be 15, right? But y plus x is going to be 12. This is all 12. So what I got is y minus x is going to be 15 over 12. Let's simplify 3 times 5, right? And 3 times 4, actually 5 over 4. Okay, so y minus x is 5 over 4, and then you have y plus x equals 12. Y minus x is going to be 5 over 4, and this is equation 1. That's equation 3, right? Or equation 4. Let's label it. Then from here you can get to the x, y. Okay, and add them together. You will get, add those 2 equations together, you get 2y equals 12 plus 5 over 4, and 48 plus 5, that's a 3, 53 over 4. It's a pretty strange number, okay? Y equals 53 over 8. Then you can get x. X is going to be 12 minus y. 12 minus y, right? 12 minus y is going to be 54 over 8. Right. So I'm going to get 12 times 8. 12 times 8 minus 53. So it's 43 over 8. So you get x and y, right? But you needed to, you needed to get h, right? H square is going to be, right? H is going to be, let's see, use one of the equation, 7 square minus x square, okay? Square root of 7 square minus x square. x squared is going to be 43 over 8. Okay, so that's it. Okay, you then you get h, right? So the area is going to be half of the base times h. So all you have to know is just the height of the triangle. So it'll be 6 times h. Okay, then you can simplify. However, for an arbitrary triangle, we do have a Heron's formula. If here's A and B and C, so S is going to be half of the parameter. Okay, then the area is going to be square root of S, S minus A, S minus B, S minus C. Okay. If you have a time, I hope you can find the way to prove this in identity. Okay, it was discovered by Heron. Okay, he thought, if the triangle 3 sides are fixed, then areas should be fixed. Areas, can be completely determined, right? And then you should be able to express the area in terms of ABC. So he tried to find the formula, and that is the formula he came up with. Okay. The idea is very similar to the above idea. All you have to do is, the proof is you draw the line and assuming C is the longest one, okay? Assuming C, you can assume C is greater than A and B, okay? So this longest side, and then you draw the line H, and then you have X, then have Y. So you get 3 equations, X plus Y equals C, and X squared plus A squared equals A squared, and the Y squared plus H squared equals B squared. So from here, you can find we can find H. Then the area is going to be, H is going to be, in terms of A, B, C, okay? You can solve for H, like as we did. Then you find the area. Area is half of C times H. Then you modify the expression, finally you can express the area using the above formula. It's a fun, if you have a time, you can try to prove that formula by yourself, okay? So it's a very useful formula. So what we did here, let's see, how do we use this formula to find here 7, 8, 12, right? Let's see. 7, if we have a triangle here, 7, 8, 12, right? So S is going to be half of 7 plus 8 plus 12. So this will be 27 over 2, okay? So that is half of the parameter. Then the area is going to be 27 over 2, 27 over this, 27 over 2 minus 8, 27 over 2 minus 12. And that's it, very quick, Right? So this is going to be 27 minus 14, right? It's going to be 13 over 2. 27 minus 16 will be 11 over 2, right? Yeah, 27 minus 24, that's 3. Okay. So what you can get is 27 times 3 is going to be 9 squared. So it's 9 over 4. And this 13 times 11. So you're not able to get the rational number, you get the irrational number. Okay, that's how do we solve the problem, okay, quickly. Okay, now if you of course, if you use above method, I think after simplified, you should be able to get the same solution, okay? Yeah, so but we get 6 times square root 17 square. Let me double check, is actually, yeah. So Yeah, let me get 6. Okay. Yeah, 49 times 64 plus 43 times 43. This is 4985 over a squared. And then that'll be divided by oops. I hope we'll get the same answer. Okay. I believe that should be okay. If my computation is correct, right? And double check. Let's see. I guess yeah. You can spend time to look at it. Okay. If my computation is correct, and that will be yeah, divided by so something's wrong here. So my computation. Okay, well I can check it later. Okay, so that should be the same answer. Okay, the idea is the same. You know, maybe there's a computation errors if you don't match the same answers. Okay, so I stop here. Okay, so you can double check and this is the idea. How did Heron get the formula? The same idea. Use apply the Pythagorean series to both sides of the right triangles. Then you solve for h in terms of ABC. Then use a basic area formula. Then you have to reorganize, the terms inside the radical, and then finally you can express the area in this nice form. Right? Square root of s minus a, s minus b, s minus c. Okay. Yeah, let's stop here.